The 555 timer may be the most popular chip ever. It was born in 1971. In 2003, it sold 1 billion pieces. It's so popular is because of its extensive applications. It can design thousands of functional circuits. And it's very cheap. Next, let's talk about its working principle and see what it is. Then, let's use this 555 to create a LED light flashing effect. The 555 timer has 8 pins. This is the function of each pin. This is its schematic diagram. On the left are 3 resistors of 5,000 ohms. These are 2 comparators. It's very simple. If the voltage on the inverting input is greater than, it will output a high level, and vice versa. This is a transistor. If you give it a high level, it can conduct. These are all analog circuits, while these belong to digital circuits. Its core is this RS flip-flop. R is the abbreviation of reset, which means reset, which represents 0, and S is the abbreviation of SET, which means reset, which represents 1. Q is the output. This is its truth table. That is, when we input 1 to S and 0 to R, outputs 1, and vice versa. But you see, the Q terminal of the trigger is also added with a small circle, which means the result is inverted. So the value of point T is opposite to the output of the trigger. This output buffer inverts the result of point T again. This is the basic situation about the 555 timer. Now we will use the 555 timer to design an application to make the LED light flash every 3 seconds. This is its schematic diagram. Its power supply voltage is 5 volts, so the voltage at point A is about 1.7 volts, and point B is about 3.4 volts. At the moment of power on, the capacitor is equivalent to a short circuit, so the voltage at point D is 0, so the inputs of the 2 comparators are 0 volts. The non-inverting input of comparator 1 is 0 volts, and the reverse input is 3.4 volts, so it outputs a low level. The in-phase input of comparator 2 is 1.7 volts, and the reverse input is 0 volts, so it outputs a high level. For the flip-flop, the output of point T is low level, so the transistor is cut off, but after the buffer, it will be inverted, and finally output a high level. The LED light is turned on. Then the capacitor will be charged. When the capacitor is charged to 3.4 volts, the inputs of both comparators are also 3.4 volts. The input of comparator 1 will start to be greater than 3.4 volts. The reverse input is fixed at 3.4 volts. The forward input is greater than the reverse input, so it outputs a high level. Similarly, comparator 2 outputs a low level. At this time, point T outputs a high level. After passing through the buffer, it can output a low level, making the LED light go out, because point T is high. So the transistor is turned on. The electricity in the capacitor will be discharged, and the low point voltage will be lower than 1.7 volts. The outputs of the 2 comparators return to the initial state. Point T outputs a low level. The transistor will turn off again. The LED light is lit again. It will continue the above process, so the LED light will keep flashing. As for the frequency of LED light flashing, depends on the resistance and capacitance we add. This is the formula for calculating the frequency. As long as we select the resistance and capacitance values, we can meet our frequency requirements. This is the duty cycle formula, which is the proportion of LED light on time. It depends on the selection of the resistance value. Using the 555 timer, we only need a few peripheral devices. We can design an application for LED flashing, but please don't underestimate the 555 timer. Although it looks simple, but it's really hard to design an innovative circuit. It is also difficult. The applications designed with the 555 timer can't be explained in several books. It's really hard to finish. Okay, this video is over here.